did a chi-squared test for homogeneity to try to answer our question: is the distribution of people who have gone to therapy in the past 6 months the same for men and women? Okay, so for our H in Hamptons, we did the null hypothesis is that there is no difference in the distribution of men and women who have gone to therapy in the past 6 months, versus the alternative hypothesis that we're testing is that there is a difference in distribution of men and women who have gone to therapy in the past 6 months. Okay, next up we have our assumptions, and for the chi-squared test we have 3 assumptions. First, the sample needs to be random, and we ensured that we did this by, first of all we did a random sample of 32 males and 32 females, and we went into the study hall in the commons and we sampled every other table and we did everyone at that table. So that ensures we have random. Next we have our independence, which is a 10% condition. So 10% of all males at ECU is greater than or equal to 32, and 10% of all females at ECU is greater than or equal to 32. So that means our sample is independent. And then finally we have our law of large counts, which means that we need all of our expected values to be greater than or equal to 5. As you can see here, 5 is the lowest number, and that's equal to 5, so that means this one is checked as well. Okay, next we got our name for our test, which is the chi-squared test for homogeneity with 1 degree of freedom. Now we have our test. For chi-squared, we use our observed minus expected squared over expected, and we do the sum of all those for each part of the matrix. So here we wrote out all of our observed minus our expected over our expected. I forgot to mention the squared, which ended up equaling 0.47. So that means our p-value is then going to be 0.49 because our degrees of freedom is only 1. No. Okay, so based on our results, we failed to reject our null hypothesis because our p-value, as we mentioned, was 0.49, which is very much greater than 0.05. And this essentially means that, assuming that our null hypothesis is true, which is that there's no difference in distribution, we have a 49% chance of randomly getting this data, and which is obviously almost 50% chance. And because of this, we do not have convincing evidence that there is a difference in the distributions of men and women who have gone to therapy in the past 6 months. Okay, our test was the chi-squared test for homogeneity with degrees of freedom as 1, and then our significance level as 0.05. Okay, so with our p-value of 0.49, Maddie and I were a little confused because we didn't expect it to be that high. And so we figured our lurking variables may have had something to do with that. Because when we went through the study hall, people were sitting at tables with their friends, and we thought that could very easily influence someone's answer in case they do or don't want to admit they go to therapy. Also, we had a handful of people ask us if we were talking about physical therapy or just mental health therapy, and we were talking about mental health therapy. And so everyone who asked, we did specify, but some people didn't ask, so they may have thought we were talking about physical therapy. So Maddie and I decided to conduct another test, and in this one, instead of doing a random sample, we did a voluntary survey. Okay, so now we're going to check over our assumptions for our voluntary survey. This one wasn't just ECU high school students, this was people from other places as well. So independent, we had 65 girls, 15 boys, 65 is less than 10% of all women ever, and then 15% is less than all men ever. So it is independent. Large counts, we got our actual numbers here of 26 women who have gone to therapy, 3 men who have gone to therapy, 39 women who haven't, and 12 men who haven't. Our expected values then are these numbers here, with our smallest one being 5.4, which is greater than 5, which is what it needs to be in order to count it for large counts. Random, unfortunately, voluntary surveys aren't random. And so we have to take all of this data that we're going to do further with a grain of salt because it doesn't check every single assumption. Okay, so the name for this test is still the same. It's still a chi-squared test for homogeneity. Degrees of freedom is 1, and alpha is 0.05 still. We're using the same method for calculating our test statistic. We just have observed minus expected squared over expected, and then the sum of all of those. And then so we did that here, and we got a test statistic this time of 2.1, which creates a p-value of 0.15, which as you can see is a lot smaller than the previous p-value of 0.49. Okay, so with our p-value of 0.15, we still fail to reject our null hypothesis, so we do not have convincing evidence that there's a difference in distribution between men and women who have attended therapy in the past 6 months. Okay, kind of comparing those 2 tests we did. First, we did the experiment out in the study hall that was completely random, and where we gave them papers and they wrote down their responses. And when we got the responses for this, we were very surprised. We definitely expected that we were going to reject the null hypothesis and that we would have convincing evidence that there is a difference in distributions. However, that's not the case. We got a pretty high p-value of 0.49, like we mentioned. So we decided to run another test just to see what the differences were. But this next test is also very flawed. It is not random. However, we tried to limit some of the other working variables that were present in the first test we did, such as being around their friends and being in groups of people. And in that test, we got a p-value of 0.15, which is a little bit closer to what we expected. So it was just interesting to see the difference in the 2 p-values. Okay, for future reference, if we were to do this again, we would ideally want to do cluster samples by going classroom to classroom and surveying people there with our slips of paper, keeping it anonymous and random. This way they won't be next to their friends, so we won't have that influencing. We also want to clarify for our experiment that we're talking about mental health therapy versus physical therapy, like how we did clarify in our survey, but not in our original experience. And then we also would just want a larger sample size just because more data will help us find more accurate answers.